Mm.
Hello all. Actually, we are a bit passionate students, right? Our technical field or our domain relates and solves with what problem solving. Actually, right? Not only our technical field or domain field, everything in the universe deals with the mathematical solving, problem solving, or anything in the universe relates with the problem solving. Actually, right? Let's delve into the deeper insights of the problem solving. Imagine a small arithmetic operation like 3 plus 4, which results in a smallest increase 7. It's just a small thing we can do without a pen or paper or in our own mind, right? Let's slightly increase the complexity. 3 plus 4 into 7 minus 9 plus 11 into 121 minus 126 plus 88 minus 90 into 8 minus 90 plus 88. It becomes somewhat difficult, right? For manual, for manual thing, it's somewhat difficult. Or please kindly assign those operations to the system. It will give the answer immediately. If it seems to be giving the answer immediately, but operating system finds somewhat difficulty to perform these operations rather than the operation 3 plus 4 equal to 7, isn't it? There's inefficiency. There's inefficiency and somewhat difficult to solve those types of problems. Actually, I think we are passionate BTech students, right? Our main domain, most of the BTech students' domain is a technical domain, right? Actually, we are as students of information technology department. Our main field, our main target domain is the technical domain. Our technical domain mainly involves or deals with what? Designing of applications, isn't it? This designing of application mainly involves with both two domains. Actually, that front end and back end and a database. Those designing of back end programming, isn't it? That programming involves based on the requirement and based on the logic and based on the company and based on the project. One should defer one type of algorithm. Actually, right? Based on the complexity of the main customer, we're designing it. Actually, right? If you want to, for example, let's just take an instance example. If you want to design a type of maps, okay, well, it have to show the path. So one should have to design the algorithm that one should it have to show the shortest path. Actually, right? And if you take an building and calculator app, right? It should add the numericals and give the result. It is simplest thing. So here, if we compare these two examples, there are there is more a huge difference. It deals with it deals just with the adding and subtracting. Here, it deals with the most algorithm, main very complex algorithm which have to show the shortest path to you. So there are inefficiency. Sometimes there must be an inefficiency in those algorithms. Actually, right? So in these inefficiency, there are in the data structures domain. As a technical student, we are most aware of the data structures in algorithms domain. There are vast number of algorithms are available in the data structures and algorithms domain. Actually, right? In this data structures and algorithm domain, as per our requirement and based on our requirement, we have to prefer the most suitable algorithm to us. But what to choose? If there are no efficient algorithm, what to choose? We have to choose that inefficient algorithm only. Then how to overcome the inefficiency of that algorithm, or how to retain that inefficiency if we want based on the requirement. How? So let us delve into the insights of those algorithms. Let us deal and delve into the deep insights of that algorithms. Okay, my name is Chandra Swaklegadda, and I am an information technology department student and bearing roll number 12E3. So far we have discussed there are vast amount of algorithms are present in our data structures and algorithm domain or in our technical programming domain. Okay, one should have to use one of the vast amount of algorithms in those in order to implement their logic and in order to for use for their business or use for a tender or project, anything, etc. One should have to build the application using that algorithm or approaching that algorithm or using the paradigm of that algorithm. There are pros and cons. There are efficient algorithms and inefficient algorithms. The assorted order of algorithms are present in the vast amount of algorithms, right? So in order to use that efficient algorithm, there is no need of restrictions. There are no restrictions. You can simply use as efficient algorithm. But coming to inefficient algorithms, if there are no another alternative for those algorithms, what should I have to use? From where I have to build those applications? From where I have to build those applications? So in that vast amount of applications, there are some inefficient algorithms which on today, up still today, it becomes hectic for the super edge computing domains like supercomputers or edge computers or any quantum computers, which remains as hectic schedules. So delving with those algorithms is not a simple task, which inculcates errors in advanced technologies like artificial intelligence, machine learning, and quantum edging and quantum computing, etc. So, resulting in these algorithms considering these algorithms could lead to what? So, for what purposes we have to use those inefficient algorithms? Okay, so we have to know that where these algorithms can be hidden, where these algorithms are to be gonna be found. Okay, actually these algorithms are classified as two types. One is NP complete algorithms and the second one is NP hard algorithms. Actually, for efficient algorithms, you require a time of need polynomial time, right? If you consider like a simple algorithm like a linear search, the worst case of that algorithm means if you have to check all the elements, your time complexity will be n elements. N elements means how many elements did you have injected, did you have given to your program, or given as input, how that much time it will check. In the worst case, in the best case, it checks only one time if it present in the first time. Okay, like that a polynomial time will present. But but coming to inefficient algorithms, say non-deterministic polynomial time complexity will be required. Okay, so how to dwell with this, and we're gonna see the insights of that algorithm. So let's delve into the insights of that algorithm. So far we have introduced about NP hard classes and NP complete classes. Okay, actually these are the classes in which the inefficient solutions and inefficient algorithms are present. Okay, actually this is a mystery for computer science department, which inculcates with the artificial intelligence domain and with the machine learning, all domains. Okay, which inculcates a very hectic headache. Okay, so we have to delve into the insights, how to record this and how to link these algorithms to the bone. Okay, before knowing it, we have to, before going into the insights of the before delving into the insights of these classes, we have to know the complexities. We are learning about it since these are very more complex, and these are very more complex is nothing but these are very inefficient, isn't it? So these are very inefficient means we have to learn about the complexity of that. We have to learn the complexity. We have to learn how complex it is. So in order to learn the complexity and in order to know the level of the complexity and toughness of the complexity, we have to know the a term and a technology is a term or a paradigm or anything. It's known as computational complexity. Okay, we have to learn about computational complexity. Why choosing computational complexity? Other than regretting the main inefficient classes, why we have to learn about these computational complexities? Why we have to know about these complexity? Why we have to dwell into these complexity without rather than leaving those inefficient classes? Means these computational complexities actually deals with the study of the inefficient algorithms. Okay, these deals with and these tells us actually it's a study of inefficient output where the input size of the input increases rapidly or accordingly. Where accordingly the input increases, automatically the output increases, isn't it? So far we have discussed and alluded about the computational complexities. Computational complexities, as we already discussed, is a study of the increasing of output, increasing of complexity of output when the complexity of input increases, isn't it? So these computational complexities arise when there is a inefficiency in algorithm, inefficiency in the algorithm, then we have to deal with and add the factor that computational complexity. And those algorithms, we are talking about inefficiency. What is that inefficiency? What can we elude any examples? మనం ఏమైనా ఎగ్జాంపుల్స్ చెప్పుకోవచ్చా అని చెప్పి డౌట్ రావచ్చు కదా. మన ఇన్ఎఫిషియన్సీ అని అంటున్నాం, బట్ ఎగ్జాంపుల్ లైక్ ప్రోటీన్ ఫోల్డింగ్ ఆల్గారిథం ఒకటి ఉంది. అండ్ తర్వాత మనకి బాగా మంచి అవేర్నెస్ ఉన్న ఆల్గారిథం లైక్ ట్రావెలింగ్ సేల్స్ పర్సన్ ఆల్గారిథం and other unknown algorithms like weather forecasting algorithms which are used for like weather forecasting and submarine ship alignment and submarine ship route. Ilantivi algorithms, there are so many algorithms present. Okay, so we have to deal with that these complexities when dealing with these algorithms. Okay, so in order to maintain those algorithms and these complexities to the bound conditions, and some advanced technologies are developed and developed. We will delve into that later. So let's discuss how those algorithms are developed. Okay, so we have actually two main classes. So these NP classes can be rectified and kept into bound with the help of those classes, and those classes are mainly classified as P class and NP class. Okay, those P class and NP. P means polymeristic class. Sorry, not polymeristic. It's a polynomial class. So far that is NP class and P class, and we have to know what is the P class and what is the NP class. Okay, P means polynomialistic class, and NP means non-deterministic polynomial class. These what is polynomial class and non-deterministic polynomial class, and these are to be divided to solve those inefficient algorithms which is class Z, NP class and NP complete and NP hard algorithms. Then what is the specialty of this P and NP? అసలు ఎందుకు దీన్ని అప్రోచ్ అవుతున్నాం తెలియాలి కదా. లైక్ P మీన్స్ P అంటే చెప్పుకున్నాం కదా, polynomial class అని. Like P means the class which is to be solved at the polynomial time. The solution which can be solved, which can be gained, which can be solved at the polynomial time. This is known as a polynomial class. This is just basic thing. And non-deterministic polynomial class, which is verifiable, which is to be verified at polynomial class, is known as NP class. Okay. This is the main thing to be considered a P class and NP class. Okay, and based on these NP class and P class, we have to set the bounds, and so many are developed and developed in order to maintain those inefficiencies in bound. Okay. Now let's discuss about those inefficiencies. So in order to maintain the inefficiency to bounds, we have main classes. We have discussed about that P class and NP class. So we have to know that inefficient algorithm classes, that is NP class and NP complete class and NP hard class. NP hard, both we have to discuss about our algorithms గురించి మనం తెలుసుకోవాలి కదా. Like NP complete, in the name itself we can know NP complete. NP complete class is nothing but it is said to be NP complete if the class is a NP, means which is to be verified at the polynomial time, and those and other problems in that class should be reduced at the polynomial time. ఒకవేళ అదే ప్రాబ్లం ఇంకా ఫస్ట్ వెరిఫైబుల్ ఓకే, అండ్ నెక్స్ట్ థింగ్ ఏంటి, సేమ్ ప్రాబ్లం అదే క్లాస్ ఉంది రెడ్యూసబుల్ అయితే అదే పాలినామియల్ టైంకి, ఇట్ ఈస్ నోన్ as NP కంప్లీట్ క్లాస్. ఫర్ ఎగ్జాంపుల్ దీని కింద లైక్ ట్రావెలింగ్ చేసే పర్సన్ ప్రాబ్లం, వీఆర్ డూయింగ్ దట్ థింగ్ నో, traveling sales person problem and three SAT problem, nothing but satisfiability approach, which is nothing but conjecture 3C and problem, 3 conjective normal form problem, like etc. And also we are considering NP hard, NP complete we are discussing from far later. Okay, but why considering these classes important other than considering the complexities? While rather than considering those computational complexities, why we are considering these NP hard and NP complete? Means first thing, let's delve into this thing. I am waiting since 10 minutes. Let us delve into the NP complete class. Okay, why we are considering NP complete as important? Okay, if we can solve the solution, and we can verify the solution at NP complete, which means it is verifiable, and we can reduce the solution, which means the P class which is equal to NP class, which turns in groundbreaking implications in whole computer science domain. It's a great thing actually. It's a great thing and worst thing. It may cause some implications also to the heavy database in the heavy database domains, isn't it? It's not a normal thing. And also let's consider NP hard class also. Like NP hard class, with the name itself, we can is the NP complete, and is the NP hard. NP complete means what? It can be verifiable at a polynomial time, and it can be reduced in and other problems in the class also reducible in that polynomial time. But this hard problem is it also can be verifiable at computation time, but it can maybe, I am saying not, I am doesn't saying not. It may be or may not be reducible to that class in a polynomial time. Okay, అది అవ్వచ్చు అవ్వకపోవచ్చు. సో దట్స్ వై వీఆర్ కాలింగ్ యాజ్ ఎన్పి హార్డ్, విచ్ ఈస్ హార్డ్ టు సాల్వ్ ఇట్. ఎందుకంటే అది వెరిఫై, అది మళ్ళీ రెడ్యూస్ చేయలేం కదా. ఓకే, దీస్ ఆర్ మేజర్ డిఫరెన్స్ బిట్వీన్ ఎన్పి కంప్లీట్ అండ్ ఎన్పి హార్డ్. మనం ఇలాంటి ఎన్పి కంప్లీటో ఎన్పి హార్డో ఎన్పి హార్డో అని కొట్టుకుంటున్నాం. అసలు ఈ ఎన్పి కంప్లీట్ ఎన్పి హార్డ్ అసలు ఎందుకు కన్సిడర్ చేస్తున్నాం? డ్యూ టు దోస్ ఇన్ఎఫిషియన్సీస్ కదా. ఆ ఇన్ఎఫిషియన్సీ మేనేజ్ దాని గురించి డెవలప్ చేయడానికి బౌండ్స్ ఉంచడానికే కదా ఈ ఎన్పి కంప్లీట్ అండ్ ఎన్పి హార్డ్ని దాన్ని చేస్తుంది. మరి దీన్ని వాడితే బౌండ్స్లో ఎలా ఉంచుతుంది, మరి దీన్ని వాడితే ఎలా చేస్తున్నాం? Like those alluding about that NP hard and NP class, NP complete. So we have to know about. So far we are saying that it is verifiable and it is reducible to that polynomial time, isn't it? Okay, but what is that reducibility and how we are reducing those? And one thing I have forgotten, and we have example for NP hard like that. A way for everyone, that is the halting problem. The halting problem is a word for everyone. So we can consider this as an example for NP hard problem. And so far we have discussed in that we are reducing to polynomial time, like NP complete can be reducible, and NP hard may or may not be reducible. What is that reducibility? Why we have to reduce it? Okay, first thing we have to know what is that reducibility. Consider there are two solutions or two algorithms, A and B. It is said to be reducible if A can be reduced, if the instance, not instance means it can be consider it in any paradigm, like consider it as an object, or consider it as a plugin, or anything. Instance of A can be reduced into instance of B by using or converting or using an algorithm, so that if we solve B, we have to get the solution of A. This is the main object behind the reducibility. So you have to solve that solution. You have to get the solution of it within the polynomial deterministic type, isn't it? We have the objective. We have started the objective with starting this motive only. అంతే కదా, ఇది స్టార్ట్ చేస్తున్నాయి కదా చేసింది. ఓకే, ఇప్పుడు ఇక్కడ బాగానే ఉంది. సో ఇన్ ఆర్డరింగ్ విత్ దీస్ క్లాసెస్, లైక్ ఎలాగంటే ఈ కాంప్లెక్సిటీస్ బేస్ చేసుకుంటూ, ఈ కాంప్లెక్సిటీస్ యొక్క అంటే ఎంత కాంప్లెక్స్గా ఉన్నాయని చెప్పి బేస్ చేసుకుంటూ, ఇన్ 1971 a scientist named, or a researcher or developer, I don't know, to limit those into the bounds, a scientist named a scientist or developer or a researcher, I don't know exactly, like in 1971 I think he had developed an algorithm to keep it into the bounds by taking an algorithm of satisfiability algorithm. By taking satisfiability algorithm into the account, he had developed an algorithm, so which we are keeping it in the bounds. Actually we have done satisfiability problem is nothing but like a three consecutive normal form, which is known as satisfiability algorithm. In short terms it is known as SAT. Okay, SAT. What SAT tells us, what the use of that SAT? the SAT asks that in the expression, give me the truth values for the expression so that that value should result in the truth value of the whole expression. సో హోల్ ఎక్స్ప్రెషన్కి మనకు ట్రూత్ వాల్యూ రావాలి, అదే SAT అడుగుతుంది. సో ఇక్కడ సైంటిస్ట్ ఏం చెప్దాం అనుకున్నాడు, సో యూజింగ్ దట్ ట్రూత్ వాల్యూస్ సో దట్ ఏదైనా దాన్ని రెడ్యూసిబిలిటీ, ఏదైనా రెండు యొక్క అల్గారిథమ్స్ని దీనికి రెడ్యూస్ చేయగలిగితే, సో యూ కెన్ సే దట్ ఇది వీ కెన్ కన్వర్ట్ ఇట్ ఇంటూ ఎన్పి కంప్లీట్నెస్కి చేయొచ్చు. దీనికన్నా రెడ్యూస్ చేయగలిగితే ఎన్పి కంప్లీట్నెస్కి రెడ్యూస్ చేయగలగచ్చు అని చెప్పాడు. అండ్ అలానే అండ్ సే లైక్ దట్ సేమ్ and the scientist, I think it's about Robert something, I don't know exactly. He had studied on his paper, he has studied about 21 algorithms like traveling space question. He has 21 algorithms. On 21 algorithms he has studied about 21 algorithms, and he had worked on and delivered on it, and he had eluded it. And okay, this is the thing they had did. And the next thing is the next big question is what is that NP versus P problem. So far we have discussed if this is verifiable at polynomial time, then how it could be solved at polynomial time. అది కనుక polynomial time దాని దగ్గర కనుక వెరిఫై అవ్వగలిగితే మరి అది వెరిఫై అయిందంటే మరి ఇక్కడ ఎన్పి కంప్లీట్నెస్ దగ్గర అదే కదా మనం మాట్లాడుకుంది. What will happen if it will be verifiable at polynomial time? Can we solve that at polynomial time? ఒకవేళ రెండింటిని కనుక polynomial time దగ్గర చేస్తే we can say that NP is equal to P is equal to NP అని చెప్పచ్చు. బట్ it can change and ground breaking implications in total computer science technology and computer science domain. సో అక్కడ చాలా పెద్ద implications జరుగుతాయి. Like implications means like optimization in the big data analytics and big databases. We are dealing with encoding, encryptioning, and databasing, etc. In encryptioning, UTF actually, or I think most of us students use UTF-18 and more UTF-8, sorry. And encryption of software developers use, I think, UTF-16 to 20 range. They are using the encryption. If we make P is equal to NP, if we make P is equal to NP, it is easy to solve and easy to hack that. There is no security for that encryption. Then what that encryption makes? Okay, we are reading about the previous NP, and that is the most unsolved and mystery problem in the whole computer science domain. Okay, what if P is equal to NP and what if P is not equal to NP? Which is important and why is important? What are the implications of that, and what are the returns of that, and what are the pros of that, and what are the cons of that? And we have to insight and delve into the deep insights of that. Okay, what if P is equal to NP? If P is equal to NP means it can be verifiable at that polynomial time, and it can be solved at polynomial time, which is NP completeness. But doing that thing can result in the data insecureness. Actually, our main advanced technologies like encryptions, databasing, and like that advanced technologies rely on the advanced NP hardness. By relying that P is equal to NP, they are easy to solve those algorithms. Means which is easy to solve means easy to access those. If we easy to access, there is the security for that encryptions. Encryptions ki security ఏది ఇంకా encryptions security లేదు కదా. And what if P is not equal to NP? మరి P is equal to NP బాగానే ఉంది చెప్పావు, సెక్యూరిటీ లేదా అన్నావు, డేటాబేస్ మరి ఈజీగా యాక్సెస్. ఇది ఒక సైడ్ ఆలోచన. మనం ఎప్పుడు ఎంట్రీ ఎక్సిట్ రెండో ఆలోచించాలి కదా. వాటి P is not equal to NP. సరే నువ్వు చాలా టైట్గా ఉంచేసావు ప్రతిదీ, అసలు ఏం సెక్యూరిటీ అసలు సాల్వ్ చేయలేవు. మరి అప్పుడు హాయిగా కదా మనకు అనిపించవచ్చు. బట్ ఇది లార్జ్ స్కేల్ ఇండస్ట్రీకి అయితే P నాట్ ఈక్వల్ టు NP బాగుంటుంది. బట్ స్మాల్ స్కేల్ ఇండస్ట్రీస్, ఎంటర్ప్రైజ్ లెవెల్ బాగుంటుంది. నాన్ ఎంటర్ప్రైజ్ లెవెల్స్కి మన వాళ్ళ కాస్ట్ పెరుగుతుంది కదా. చిన్న కాంప్లెక్స్గా చేసేదాన్ని మనం పెద్ద కాంప్లెక్స్గా చేస్తుంటే మరి వాళ్ళకి కాస్ట్ రెడ్యూసింగ్ కదా. సో దీని ఈ ఈ యొక్క కన్ఫ్యూషన్ని బౌన్స్గా ఉండడానికి అక్కడ మనం కుక్స్ థియరం స్టేట్ చేసింది వాడు చేసింది. So there are implications for P is equal to NP and P not equal to NP. If P is equal to NP, there must be a problem. There must be problems arise at advanced technologies like databasing and encryptioning, cryptography, and mainly in AI and machine learning, like in the neural links, etc. While making neural links, etc. Because it is easy to solve this algorithm if P is equal to NP, which is verifiable at polynomial type, which makes hackers easy to hack or easy to accessible. P is not equal to NP, but this is also maintaining this P is not equal to NP also important in terms of thinking of small scale industries and non-enterprise level industries. Okay, and like that so many implications are there. But regarding comparing, we can consider as P not equal to NP is very sorry. P equal to NP is remaining, means I am saying that retaining P is equal to NP is so important. ఎందుకంటే అలా కష్టంగా ఉంచడం ఇంపార్టెంట్. ఎందుకంటే స్మాల్ స్కేల్ ఇండస్ట్రీస్ ఉన్నాయి, బట్ చాలా డేటా లాస్ అయిపోతుంది ఇక్కడ స్మాల్ స్కేల్ ఇండస్ట్రీస్ గురించి ఆలోచిస్తుంటే. That P is equal to NP and P not equal to NP, and we have decided that retaining P is equal to NP is so much important, since NP hard and NP complete are very interactable, okay, are very interactable on P is equal to NP, such as because they are big inputs and they rely on the P is equal to NP. So retaining the P is equal to NP is so much important. Let us consider real world examples in AI and machine learning, like maintaining that maintainable balance trees and also maintenance neural links mainly rely on that optimization, right? And also like if you consider traveling salesperson, it also mainly rely on the input, and also we have to make it complex, so that finding the route must be optimized. If we make it easy, how it can be optimized? Okay, so there are some implications, but maintaining the P is not equal to NP also very important. Okay, so for the small inputs, then how the దీని గురించి ఆలోచిస్తున్నాం లార్జ్ స్కేల్ ఇండస్ట్రీస్ గురించి. స్మాల్ స్కేల్ ఇండస్ట్రీస్ గురించి మరి వాళ్ళకి ఆప్టిమైజ్ సొల్యూషన్స్ కావాలి, వాళ్ళకి లో ఆఫ్ కాస్ట్లో కావాలి. మరి ఏం చేయాలి, వాళ్ళని ఎలా బౌండ్లో పెట్టాలి? So in order to maintain that, there are some techniques which inculcates the almost solution but not the total this P equal to NP solution. Okay, almost అలానే అవుతుంది కానీ ఇది మాత్రం అవ్వదు. Like using greedy methods చేయొచ్చు. లైక్ ఇప్పుడు ట్రావెలింగ్ చేసే పర్సన్ ఇలాంటివన్నీ ఉన్నాయి. ట్రావెలింగ్ చేసే పర్సన్ 0.1 నాప్సాక్ ఉంది. లైక్ అదొక మినిమం కాస్ట్ కవర్ పెట్టుకోవడానికి అది యూజింగ్ గ్రీడీ మెథడ్ చేయొచ్చు. అండ్ యూజింగ్ ఆప్టిమైజేషన్ అనేది ఇంకొక అల్గారిథం, ఇంకొక పారాడిగ్మ్. యూ కెన్ ఫాలో దట్. సో ఎలా ఆప్టిమైజ్ అవుతుంది ఏంటి అనేది ఇంకా అక్కడ బేస్డ్ ఆన్ రిక్వైర్మెంట్. అండ్ తర్వాత హ్యూరల్ హైరార్కీస్ ఉంటాయి, హ్యూరల్ టెక్నిక్స్ ఉంటాయి. Like ant colony problem. I think everyone should be aware of that ant colony problem. Using the Hura techniques use చేసి కూడా ఆప్టిమైజ్ చేసుకోవచ్చు, అండ్ వీ కెన్ ఫైండ్ ఆప్టిమైజ్ సొల్యూషన్, బెటర్ సొల్యూషన్. మన ఫైనల్ గోల్ అదే కదా ఏం చేసినా. సో లైక్ దట్. అండ్ ఆల్సో చెప్పా కదా బిగ్ డేటా ఇన్పుచ్చుకున్న P is equal to NP, స్మాల్ స్కేల్ ఇండస్ట్రీస్కి P not equal to NP. అండ్ ఆల్సో వైల్ కన్సిడరింగ్ ఇప్పుడు రియల్ వరల్డ్ ఎగ్జాంపుల్స్లోకి వెళ్దాం. ఫస్ట్ కన్సిడర్ లైక్ లాజిస్టిక్స్ అంటే ఉంది, లైక్ అమెజాన్, WPS and APSRTC, నాట్ APSRTC, ఇన్ స్టేట్ రోడ్ ట్రాన్స్పోర్ట్ కార్పొరేషన్. వాళ్ళు ఎలా ఫాలో అవ్వాలనేది మనం ఇక్కడ ఇచ్చేదాన్ని బట్టి ఉంటుంది కదా. ఇక్కడ మెయిన్లీ అసలు మెయిన్లీ if we go into the textbook references, he talks about the logistic, which is a NP hard problem. Actually this AI, big data analytics, machine learning, like these logistics problems, it mainly depend on the NP hard problem. So these logistics and advanced technologies like AI and machine learning mainly rely on these optimizations, and mainly rely on this this NP complete and NP hardness. Like this, దీని మీద డిపెండ్ అయ్యి ఉంటాయి. ఇఫ్ యూ గో ఇన్ ద టెక్స్ట్ బుక్ ది హ్యాస్ స్టార్ట్స్ విత్ ద ఎగ్జాంపుల్ ఆఫ్ దిస్ traveling this person only, because due to that rootedness in the exam all depends on this P is equal to NP. And then what about small scale industry? A doubt will be arise in your mind, and then what's about this? మరి ఇదే ప్రాబ్లమ్ని స్మాల్ స్కేల్ ఇండస్ట్రీస్ చేస్తే అలా ఆల్రెడీ కన్వేడ్ అబౌట్ ఇట్. You can use greedy methods and approximations and the heuristic methods, like etc. Heuristic methods example for ant colony problem, like ఇలాంటివన్నీ వాడుకోవచ్చు. అండ్ ఇప్పుడు ఇక్కడ ఇలా ఇక లాజిస్టిక్స్ లైక్ ఏ అండ్ మిషన్ లెర్నింగ్ వచ్చేసరికి ఇంకా అక్కడ ఉండే డెసిషన్ ట్రీస్ ఇంకా అలాంటివన్నీ. ఇంకా మరి రియల్ వరల్డ్ ఎగ్జాంపుల్స్ లైక్ నెట్వర్క్స్ ఇలాంటివప్పుడు ఎలా, లైక్ ఇప్పుడు క్రిప్టోగ్రఫీ ఉంది. సో ఆర్ఎంఏ రిమోట్ మాడ్యూల్ యాక్సెస్ ద్వారా ఓవర్ నెట్వర్క్ ద్వారా పంపించుకోవచ్చు. సో దట్ వీ కెన్ రిటర్న్ P ఈజ్ ఈక్వల్ టు NP. సో అలా మోడిఫై చేసుకోవాలి. సో maintaining the NP hardness and NP completeness is truly based upon your requirement, and truly by using the Cook's theorem and another theorem, Robert's theorem or anything, I don't know the name exactly. We can retain that and we can maintain that inefficiency up to the bounds. We can cut it, we can cut the edge up to the bounds. Okay, so it's truly based upon the one's requirement, and we can know by, so we can conclude that, so I want to conclude it. So we can conclude that it's truly based upon the your requirement. This algorithm mainly tells us, it doesn't give a actual solution. It mainly tells us what we can restrict and to what extent you can restrict and what extent we can retain. It's not a simple thing, it's a groundbreaking thing for the whole computer science domain. It's a and the whole computer science domain is for the whole computer science domain, it's a groundbreaking thing. And in the whole domain and whole data structures, it's a mystery thing up to still now. ఇప్పటికీ unsolved mysteries అవన్నీ. So it's truly based on one's requirement. So hope you all understood. It's a recent topic, so I doesn't have so that much clarity regarding it. So hope Narayan sir, you will watch this video up to the last, and